main active elements, the active element that plays a key role in organic compound is what? Which element plays a very vital, one particular element there? Carbon, Abi. Carbon. And among the 118 chemical elements we have, carbon is so unique, very unique. You know what I mean? Unique. Is unique in a way that carbon is one element that's easily form bond with itself. You will hardly see an element that bond with itself. Okay, you know what I mean by that? You see one carbon, you cannot see sodium do that. Na, no, it's not possible. You see carbon, you now see carbon, it will point to another carbon. It will not stop here. The chain may continue from here to that post, or from here to Aquata. Only carbon going in that chain. What do you call that tendency for an element that form bond with itself? What do you refer to that as? Catenation. Sometimes you see a question like this: which of the following element catenates? The element that can catenate. There are elements that catenate, but it is very simple for carbon to catenate. So catenation is the what? Is a uniqueness that differentiates or distinguish carbon atom from other what? Elements. Catenation. It can easily form bond. What is catenation? Ability of that carbon to form bond with what? Itself. Silicon can also form that bond, but it is not as that of carbon. If you compare silicon with carbon, you find that the size of carbon is considerably very small size. So element with small size can easily make bond with it what? Self. So that is one uniqueness of carbon that you should know. And also, it can also easily make bond with elements, other elements apart from itself. It can make bond with element like what? Hydrogen, as you see in hydrocarbons. You know the hydrocarbons now, isn't it? The compound that contains carbon and what? Hydrogen only. Apart from making bond with hydrogen, it can make bond with other elements like what? Non-metals, halogen, even metals, phosphorus. Many non-metals it can make bond with, most especially oxygen. It makes bond with oxygen, it makes bond with nitrogen, it makes bond virtually with all non-metals, and also make bond also with metals, like you see in Grignard, magnesium halides of what? A key group. It makes bond with metal, most especially magnesium. So these are the uniqueness of carbon. And all of this uniqueness, there is one that stands carbon out. And that one that stands that carbon out is that carbon can also make multiple bonds. I think you know what I mean by multiple bond. More than one bond, Abi. So apart from the single bond it will easily make it can also make what? Multiple bond. That is why we have saturated and what? Unsaturated organic compound. Because of that multiple bond, it can make carbon-carbon double bond or carbon-carbon what? Triple bond, as the case may what? May be. So if you now collate all these things together, and the fact that carbon is one element that its compound can easily isomerize. You know the term isomerism? You know what is isomerism? Where you see a compound, a single compound, forming another thousands of compounds. Do you understand my question by this thing now? An organic compound may form two or more compounds. Okay. I've been signal now that we are ready. Please, we are going online now. And I want it to be of your good behavior. Anything that you consider very vital in this class, please make sure you jot down. Okay, make sure you jot down. If you have any question, you just raise up your hand. A mic will be given to you. You ask your question, and every question here will be attended to. Okay, now I will join the online people to now deliver this epic lecture to you. It's an epic lecture in an epic occasion like this. This will be your defining moment. I want to tell you simple truth. This is your defining moment. I want you to be very serious about it. Be very serious. So many things we're going to say here. That is exactly how the question will appear. No two ways about it. I'm telling you. So now we start immediately. Now, we'll be taking on the aspect of organic chemistry 3. Chemistry, organic chemistry. Organic chemistry 3. Organic chemistry 3, you see like what? What do you have here? Carbohydrates. There's some class, I've started this already. So carbohydrates, I will just touch key areas. I'll touch key areas, but I have questions. I don't even need to go through your past question here. I have ones that I can manufacture. We have done something of this before, carbohydrates. Now I'm going to just start with the naming. The organic compound that if you want to name them, of organic compound. Okay, there are rules governing organic compound. Like in carbohydrates, who can tell me the functional group? There are two functional groups, basic functional group in carbohydrates. Who can tell me the two functional groups? Number one is what? RDA. The chemical bond attaching to hydrogen should be how many here? 1. So this is the structure of the hydroxy group, the two functional group. Hydroxy group and what? Alkanal or aldehyde. Now, just like you know what is functional group, the reactive group of a molecule. Solubility of glucose or any carbohydrate in water except starch. The reason why starch is not soluble in water is because of what? The molecular weights. But mind you, starch is soluble in hot water. That is one distinguishing factor between starch and what? Simple sugar, like what? Glucose. Solubility of glucose in water is because of what? Hydroxy bond, because it's going to interact with water and oxygen of the hydroxy group of. Glucose is a reducing sugar. That is another carbohydrate example. Is a reducing sugar because of what? Because of what? Aldehyde or what? Alkanal. This is what gives it that property that seems it's referred to what? A reducing agent. All the things you know about reducing agents is same in glucose or any sugar with alkanal group. Any sugar with alkanal group CHO have the tendency to what? To lose what? Electron. Are you with me? Any sugar that have CHO will easily do what? Lose what? Electron. Take note. Reducing agents are electron donors. They are electron what? Donors. In the course of the lesson, we're going to really ascertain the two reagents that can be used to confirm the presence of reducing sugar in the lab. We're going to look at Toluen's reagent, Benedict solution, and then what? Verhelyen what? Solution. These three key mild oxidizing agents. They are mild oxidizing agents. They are mild in the sense that they are the only agent that can easily accept electron from what? Glucose. And if they do accept electron from glucose, what happens? Glucose become oxidized. In the process of being oxidized, what happened to that Verhelyen solution? They become what? Reduced. And if they become reduced, then will you know that the reaction has taken place? Color change. You see the color will what? Change. The active ingredient in Verhelyen solution or Benedict is copper 2. But at the end of the reaction, you see you're not going to see copper 2 anymore. What you will see, and that is a simple truth there. The property that gives that sugar that reducing ability is what? Alkanal or what? Aldehyde. Okay, now, you must also know that, take note that over the years, Jamb have been defined carbohydrates. I don't know whether they are going to change their mind this time, because someone like some of us have faulted that definition of carbohydrate. I think I told the other class, medical class, the last time, where if you open these past papers, you see over the years, carbohydrate has been defined as organic compound, which contains what? Carbon, hydrogen, and what? Oxygen. In the ratio of what? 1:2:1. I told the other class that I have a problem with this definition. But if they ask you which of the following best describe carbohydrate, and if you see this, please go for it. I also mentioned that see, what is that compound again? Those in the other class. Ethanoic acid. That is what? CH what? 3COOH. Whose molecular formula is what? C2H4O2. The empirical formula of this particular organic compound is the same thing as what? 1:2:1. Does it mean that this organic compound, is it a carbohydrate? It's not, but it's having ratio 1:2:1. From the definition, it simply means that any compound with 2:1 ratio, carbon 1, ratio hydrogen 2, oxygen 1, is typical carbohydrate. That is what that definition means. That organic carbohydrates are organic compound that contains carbon, hydrogen, and what? Oxygen, in the ratio of what? 1:2:1. For someone like me, it is what is in your syllabus, but I am telling you here that it is not probably correct, because there are some organic compounds that still have that same formula, but still yet they are not what? Carbohydrates. So what is the best definition for carbohydrates? I've told you the other class. I'm seeing it again now. Any compound that have many OH with what? CHO. Many. You know what I mean by many? Any compound that have more than OH, more than one OH. More than what? One OH. With what? CHO or what? CO are what? Carbohydrates. A compound that is what? Polyhydroxyl aldehyde. I think I said it last time. Please, those that are not in that class, please get to know that. Compound with many OH are poly. Poly means what? Many. So carbohydrates are polyhydroxyl what? Aldehyde. Or guinea polyhydroxy what? Ketones. Now, if you look at what that definition is trying to explain, it is still in order with ratio 1:2:1. But it tried to isolate this one from the compound. Because how many OH is in this CH4? CH2, C4O2. How many OH is this compound? How many OH there? How many OH is here? 1. Let's draw it. How do we draw this CH3? C1, H what? 3, CO, then what? O what? H. How many OH do we have there? 1. Is it many? It's not many. Is this an alkanal? An alkanal must be what? CHO. Is there any alkanal here? No. You see, now we've been able to use this definition to sideline this compound. But all other compound of carbohydrate falls in the category of what? Having many OH group with either what? Alkanal or what? Alkanones. That is carbohydrates. That is what? Carbohydrates. A compound with many OH. And if you look at glucose, how many hydroxy group are there in the molecule of glucose? How many OH are there in the molecule of glucose? Look at me. How many OH are there in the molecule of glucose? The answer is what? 5. In the molecule of glucose, there are 5 hydroxy group. And that 5 hydroxy group there is what is responsible for its solubility in water. That is why it is soluble in water. Because that hydroxy group interacts with water by forming what? Hydrogen what? Bond with it. Then if you are naming those or glucose, said it before, if you're naming organic compounds like glucose, you should know that the functional group are alkanal and OH. And you know, there are some functional groups that are carbonyl. They are carbon-based functional group. All carbon-based functional groups are called what? Carbonyl. Like this CHO is carbon-based what? Functional group. So it's carbonyl. Then the OH is not carbon-based functional group, so it is not carbonyl. So when you are naming an organic compound that have two functional groups, and if one is carbonyl and the other one is not carbonyl, please, the carbonyl will take precedence in that compound. Do you know what I mean, precedence? We take charge. For instance, now, supposing I have a structure like this, I have something like 1, 2, 3. I have NH2, and here I have COOH. So who can help me with the name of this organic compound here? Who can tell me the name of this organic compound? The IUPAC name of this organic compound. How many functional groups are in the organic compound? How many functional groups? 2. One is what? The amine, aquia. And the other one is what? Carboxylic group, aquia. Which one is carbon-based functional group here? COOH. That one will take precedence. Precedence means that one will be number 1. This will be number what? 2. Here's what? Number 3. Then how then do you now name this functional group? You name it as a prefix. You know what I mean by prefix? It's not going to come as suffix. The one that comes as suffix is the main functional group. The main functional group here is COOH. So it's going to come as the last. So this one is going to come as what? The first. As what? 2 what? 2 amino. It becomes 2 amino. How many carbon are there in the long chain here? 3. So 3 is what? Prop. I've always said this when you see 3 carbon named as prop. Is those 3 carbon linked with single bond? Yes. So what do I put here is what? An. Then what then is the suffix for COOH? OIC. Make sure you end it with what? Acid. But in the case where this is not there and you have something like CCC, NH2. So how do you name this as now? Now, the principal one is NH2. So what are you now? So you can name it as a principal, the main functional group. It doesn't have COOH competing. So in this case, you are not going to name it as amino, but you're going to name it as what? Amine. How many carbon are there in this long chain? 3. So this is what? Propyl. You know why it is propyl? Because C there is 3, H there is how many? 7. It's propyl. Then what is the suffix for amine? Suffix for amine is amine. So what's the name now? Propylamine. It will be an amine if it is not competing with a carbonyl functional group.